Alright, today we got prisms. So first thing here is draw a net for a cube. So we kind of talked about that in the last lesson. So I'm going to draw a cube, what I think a cube would look like with a net. And then I'm going to show you how to go back and mark everything. Draw something that kind of looks like that right there. Something that's going to fold back up into a cube. And then since cubes, all the side lengths are the same, I'm going to go ahead and mark them all the same right here. And then I guess if they want each side to be 6 inches, I'll label one of them there. And then since I got my congruent markings, then we are good to go there. We don't need to put any additional things. So that should all fold back up into a cube there. I draw a net for a pentagonal prism with a height of 5 inches and a side length of 4 inches there. So pentagonal prism, so I know I need a pentagon. I just try to draw kind of like a regular pentagon, I guess, if I can. Now pentagons, they're a little tricky to draw. Right, and then kind of refer to why I just drew a rectangle there. Okay, so the whole idea here is, here's one of your bases right here. That's one of your pentagons, and then another one of your bases right there. So those will be the top and bottoms. But in between each of those side links right here, each of the sides of your pentagon, there should be a rectangular face right there. And that'll be like your lateral edge part of it. And then we're going to draw out, actually, we're going to draw out a few of those. Since when you close it back up, you want to have 5 main sides. Since it's a pentagon, I'm going to draw 5 of these rectangles. Kind of like that. And then I'll mark all these sides need to be congruent. And it said with a height of 5. So remember, the height between two objects, that's going to be the distance between the bases there. So I'll put 5 inches right there. And then each of the side lengths will put 4 inches. That right there, and then those actually kind of match up with the tops of these rectangular faces right there. So there you go. So that's kind of how you can do the nets right there. How could you use this information to find the lateral and surface areas? Well, if you have it unfolded, just take all your areas, and I'll say so take all maybe two-dimensional areas and to add them. And that can help you find either your total surface area, or if you just wanted, just a lateral area, you take all those rectangles and add them up. Okay. So here's a little bit of vocab, a prism. So that's kind of what we're focusing on today. This is a polyhedron with 2, and we're going to say congruent, and also at the same time parallel bases right there. So 2 congruent and parallel bases. So for example, this pentagonal prism, there's your 2 bases if you were to fold them back up, and those would need to be parallel to one another. Okay, prism is named for whatever the shape of the base is. Okay, a prism has 2 bases. The rest of the faces are called, I guess we call them lateral faces. And then also you have an edge. An edge of a prism is perpendicular, or is a perpendicular segment that joins the planes of the bases. Okay, the length of the altitude is we call this thing the height, which basically, maybe even a better definition, the height is the distance between, and we should even say the perpendicular distance, actually. Let's add that in there. The perpendicular distance between 2 bases. All right, and that height's always in between the 2 bases, and I'll kind of show you how to identify that here on these next few problems here. So In a blank prism, the lateral faces are rectangles and the lateral edge is an altitude. And we just say that's in a right prism. And most of the prisms that we do work with are going to be right prisms. Okay, so a couple of your prism formulas. Okay, just like the cylinder, you take your circumference, but instead of your circumference, you're going to have the perimeter. So you're going to take your perimeter and you're going to multiply by the height right there. And since each shape's going to be a little bit different, we don't write out a formula for the perimeter. We just say the perimeter of whatever you're considering your base to be. All right, and then the surface area, you're going to have two extra bases. So we'll go pH plus 2b. And you know what? Let's go ahead and draw something out here so we can refer to something. So I'll make maybe this triangular prism kind of going up and down, kind of like this. So yeah, perimeter, so your bases would be those right there. Those would be, you know, the triangular bases right there. This is a triangular prism. So you would take the perimeter of your triangle and then multiply it by the height. And then to add on the two bases, well, you need to find the areas of your two triangles here. And then multiply that by 2. And then for the volume you're going to do area of your base times height. And that's kind of like the circle one, or the cylinder one, where you did the area of the circle times the height. Here you do the area of the triangle times the height. And that's how most of the formulas are going to appear on your star chart. Now if I wanted to draw, I guess, a net for this figure right here, I guess you could draw, you know, two triangles. Kind of want them going kind of like that in opposite directions there. And then there'd be 3 lateral faces. And then that thing should fold all the way back up. Right there. Now as far as your cube formulas, this is where it's a little bit more specific here. So for your lateral area, your perimeter of your base right there, that's going to be, you know, 4 different sides right there. So you take 4 times the sides. So 4 of the sides, whatever that is, and then you actually multiply it by the side because that's the actual height. So it's going to be 4 sides squared. Surface area, you got to add 2 of the bases right there. So you're going to add on 2 of the area of the sides. So you'll get 6 sides squared once you do it all together. It's basically 4s squared and then plus 2s squared. And then you can combine your like terms. And that'll be how it appears on the formula chart. Alright, and then for your volume, it's just side times side times side. For volume of prisms, especially rectangular prisms, there's kind of this thing you might have learned in middle school, like length times width times height. But here it'd be side times side times side, since it's the same thing. And I think we already drew a net, so I'm just going to quickly draw a not super pretty one, but there's your net right there of a cube. Okay. Now this next thing, find the lateral area, total area, and volume of the following figures. And actually, so with rectangular prisms, it depends on what you consider the base to what you consider the lateral area. So lateral area, it's kind of, it depends on what you call your base. So actually, probably shouldn't even have that. Oops, yeah, it depends. So you got to be kind of careful there on that as far as the wording. Now, most of the times we assume the base. We'll go ahead and consider the base the bottom, but it doesn't necessarily always need to be the bottom. You can make the base of your prism the actual side, which changes your height right there. So I'm going to consider, for my formulas, because it kind of helps me out, I'm going to consider the bottom to be the base right there. So if that's considered to be my base for the lateral area part of this here, we need to do the P times the H. So we need to find the perimeter, and then we also need to identify the H. And here's how I kind of do these. I just list out all the pieces, and then I go plug them all in. So the perimeter here, you got 6, and then 8 right there for your dimensions. So you'll add those up, and then you can double it, or you can do 2 times 6 and then 2 times 8 and then add them up. Anyways, whenever you do that, you should get 28 units right there. Now, as far as the height goes, the height has to be going between your bases. So the base is considered the bottom and I guess the top. So the height's going to be in between that. That's going to be the 5 units between that. And then after that too, you can go and also we need to find the area of the base. We'll need that for some of our formulas. So the area of the base, that's 6 times 8, or that'll be 48 right there. And then now we can go plug everything in here. So P times H, that's 28, and then times 5 right there. And let me punch that out. I don't have that written down in my notes. 28 times 5. So that's 140 right there. And then I guess meters squared. But then for the total surface area, or the SA, or the surface area, or total surface area, depending on what you call it, you're going to take that 140 meters squared, and then you're going to add on the 2 bases. So we need to do 140 and then plus 2 times 48. And then whenever you punch that out, you're going to get apparently about 236 meters squared. And then, so that's your total surface area right there. Here's your lateral area if you consider in the bottom of the base. And then the volume, you're just going to go and do the big B times H. So that's 48 and then times 5. And that gets you 240 meters cubed. All right, and those are all of your different dimensions right there. So we can put, 236 meters squared and then 240 meters cubed right there. So next one here. Given that the lateral area, this is again one of these problems here, I'm thinking we're going to have to assume something. I think we're going to have to assume the base is the bottom here, especially since they gave us those dimensions right there. So based off of this, given that the lateral area is 40 meters squared, assuming the base is the bottom side, we can go find the total area and volume. First of all, we need to go find the height here. So let's list out the P, the H, we need that. The area of the base, we'll need that as well for all of our other formulas. So the perimeter, you need to do 6 plus 4 and then plus 6 plus 4 again for the perimeter right there. So I think that should get us to 20. And then since the lateral area, they gave us that's usually P times H, we're going to go 20 times H, and then apparently it equals about 40 right there. That's what they gave us there. So if we divide both sides by 20, we get H is equal to 2. So that height going up and down, it has to be 2 right there. And then therefore, after that, now we can go find everything else. Also, the area of the base, we could have gotten that from the beginning. We would have said that was 24 right there. And then we can go and punch out the rest of your formulas. So height, that was 2 meters. Total surface area, that's going to be 40. So that's your lateral area. And then plus 2 times your bases. So 2 times 24. And that gets you 88 meters squared. And then for volume, you're going to go big B times the height. So that's 24. Then times 2. That'll get you 48 meters cubed. And then there you go. Notice that the height, that's a one-dimensional unit there, so I just put regular meters. Okay, given that the volume is 105 meters cubed, go find X and then go find your lateral area and surface area. So look at this here. Kind of multiple ways you can do this. There's not one way you can do it. So I guess the way I have it on my key right here, I'm going to consider the bottom the base. This kind of matches up with the notes that I have written down. So we say volume is big B times H, but right now we know that the big B is going to be whatever 7 times X is, so we'll just write it as 7X. Now the height, we do have that'll be 5. So plug all that stuff in, and then what did they say the volume was? 105. So we'll say 105, and then equals 7X, but then that'll be times the height 5. So essentially when you multiply all that together, you're going to get 35x equals 105. And then just divide both sides by 35. And then I think that gets you x is equal to 3. And then now that we have that, we can go plug 3 back in to figure out the area of the base should be 21. The perimeter of the base, we also need that. That's 7 plus 3 plus 7 plus 3, so that should be 20. And then now we can go find the rest of our dimensions. So we got, well, actually we already found the other dimension. Now we can go find the lateral area and surface area. Once again, the lateral area, I'm assuming they're going to consider the base right there, the bottom right there. So if we're going lateral area, that's going to be P times H. And based off of that base right there, I guess we'll go 20 and then times the height 5. Okay, so I guess we'll say that's 100 units right there. So what is that, 100 meters squared? And then for the surface area, you want to go 20 times 5 and then add on your 2 areas of your bases. So add on 21 twice right there, and that'll give us 142 in the meters cubed. Okay, once again, lateral area kind of just depends on what you consider in the base. Given the volume of this cube, which is 216 meters cubed, find the edge and the total surface area. So this one right here, the cube, they give us the volume. We're going to use our formula. You could use the formula, you know, B times H, but we had that shortcut formula. We're going to say it's the side cubed. We got 216 equals the side cubed. So actually you're going to do a cube root of everything, and that gets you that the side length is 6 right there. So we'll say one of the edges is 6, I guess, meters. And then your formula for total surface area, if you want to do that, total surface area was 6, and then side squared, so 6 times 6 squared. So actually this is a weird case where it comes out as the same numeric value as your volume right there, 216 meters cubed. So I was using those shortcut formulas for surface area and volume there. Okay. SAT question, a rectangular prism has a length of 8, width of 3, and a height of 5. What is the distance from the top back left corner to the bottom front right corner? So this is actually kind of weird here. This is, imagine that you have a rectangular prism, kind of like this. And you're finding the distance from one of the, you know, back corners to one of the front corners. So it's kind of weird here. So what I like to do here on this problem is think about first of all, what's the distance from this front corner to this back corner along the base. So I'm going to draw this dotted line. It's kind of hard to see, so I'm going to redraw it. It's like a top view. So if I was looking like helicopter type of view, I'm going to find this dotted line right here. Find that length right there. Now let me go label all of my dimensions here. It really doesn't matter where you label them here. I guess a length of 8, a width of 3, and then a height of 5. So as far as the bottom or the base or whatever we're considering the base, this is going to be an 8 by 3 right triangle there. We're going to assume that this is a right prism here. So the whole idea is we're going to find the diagonal length right there. We're going to find that by using Pythagorean theorem. So we'll go and do 8 squared plus 3 squared equals c squared. Okay, so then we can go and punch that out there. So that'll be, what is that, 64 and then plus 9 right there. So that should get us 73 equals c squared. So then c is just square root of 73. And I'm going to write that in. So that's that distance going down there along the bottom. So the whole idea now is we're going to make this right triangle that's like kind of standing up inside of your figure. So this is a right triangle inside of the figure, kind of going diagonally. So now with that blue dotted triangle, I'm going to just redraw that triangle right here. Now the height should be the same. The height should be still going up and down, but that diagonal distance was the square root of 73. And then I'll just, call this other side here x, that distance right there that we're trying to find. So then we'll go square root of 73 squared, and then plus 5 squared, and then equals x squared. Now here's the nice thing, when you square a square root right here, those cancel each other out. So this is just going to be 73, and then plus, 25, and then equals x squared right there. And then I think that gets us 98 equals x squared. And then you can square root both sides. Okay, and then I think 98, that breaks down to 49 and 2, and then 7 and 7. So that'll be 7 square root 2 for your final answer. And then whatever the units are here. Yeah, they didn't give us units, so we'll just say 7 square root of 2 units right there. So that one's pretty advanced right there. That's just about as complicated as you get right there. So kind of using all the edges. So now that we know how to do that, we can do this problem here. So you got a cube with a volume of 125 cubic inches is inscribed in a sphere such that each vertex of the cube touches the sphere. What is the radius in inches of the sphere? So essentially, we have a cube, and it's kind of hard to draw the picture, but I'll do it as best as I can. And it's in some type of sphere right there. And essentially, if we can find from corner to corner, just like we did in that last problem, we can go and find the radius. That right there from corner to corner theoretically should be the diameter right there. So if we can find the diameter, we can divide that by 2. And go find that corner to corner distance there. So we're going to try this here. So first of all, the volume of the cube is 125 units right there. And then remember, your volume formula says that you just do your side and then cubed right there. So when you cube root it, it sounds like each side's going to be 5 units right there. So I'm going to say this is a 5 by 5 by 5 cube right there. And then just like the last one here, we got to find that diagonal distance, which is this right here along the bottom. I'm going to do some dotted lines there. So we need to find that diagonal distance right there. So notice here you're going to have 5, 5, and then once you use your Pythagorean theorem, you'll get, well, here, let's just write it out. So that's 5 squared plus 5 squared, and then equals c squared. So that's 25 plus 25, that's going to be 50. Equals c squared. So we'll say it's square root of 50 for c. And actually, I'm going to leave that, since I'm going to have to, that's not my final answer, I'm not going to worry about simplest radical form there. So that means we got square root of 50 going down there along the bottom. So then we'll redraw another triangle here, square root of 50. And this is to get that diagonal distance there. So square root of 50, and then you got 5. And we're going to try and find that distance there, x. So that'd be square root of 50 squared plus 5 squared, and then equals x squared. So that'll be 50 plus 25 equals x squared. That's x squared equals 75. And then I think once you break that down in the simplest radical form, what do we get there? 25 and 3, so that'd be 5 square root of 3 for your distance there, x. Now that x distance is actually your diameter, so we'll say 5 squared of 3, and then if you want the radius, you need to go back and divide that by 2. And then that'll be in inches right there. So kind of a tricky question there. That's not an easy one right there. Okay, hexagonal prism. So this is a prism. The shape should be a hexagon. I'll just try to draw that as best I can right there. And all your edges. And I'm not going to worry there about the back side there. But it has a base edge of 6. and then a height of 8 going up and down, I'm assuming. Find the lateral area, total surface area, and the volume. So actually, the area of the base is the tricky part in this problem right here. The base is a hexagon, so we need to go back, and our formula for the area of a hexagon, you use that 1/2 the apothem times the perimeter. Alright, so we hadn't used that in a while. We're going to use probably some special right triangles there for that. So remember, inside of a hexagon, this is a couple units ago, we can draw a special right triangle inside of your hexagon. You're going to have a 30, 60, 90 triangle inside. And then since each side length is 6, that half side is going to be 3. Then we can go and label all of our ratios. Now I'm going to just redraw the triangle out here so I have a little bit more room to work with. I'm trying to make it look a little bit better. There we go. So you got 3, and then remember the way you label your ratios is x root 3, and then this is 2x. So that radius there should be 6 because your x is 3, and then this apothem going up and down is going to be 3 square root of 3. So we need that. You need your little a is 3 square root of 3. Your perimeter, we need that. The perimeter is just 6 times 6 right there, so that would be 36. So then to find the total area of your base, we're going to go 1/2 the apothem, 3 square root of 3, and then times the, wait, why did I say 1/2? 1/2 right there, and then, yeah, times 36. So I think that's like going to be like, maybe like 18 times, here, let me punch it out here. 36 divided by 2, yeah, 18, and then times 3. So that'd be 54 square root 3 for your area of your base. So that's actually your big B. So a lot of work to get your big B, but it is 54 square root of 3. You're going to have your perimeter. The perimeter is still the same. The perimeter of your base is still 36. And then now the height is 8. And then now we can go find volume, surface area, total, what do we got? Volume, surface area, and lateral area. Lateral area, perimeter times height, so that's just 36 times 8. And you're going to get 288. And I guess I should write it out here for your notes. 36 times 8, so that's 288 in the meters squared. Surface area is going to be P times H, and then so the 288, and then we need to add on the 2 times the bases right there. So we need to go 2 times 54 and then square root of 3, and we'll leave the square root of 3 in our answer. So actually the way you can write it is 2 different ways you can write it. You can just write it like this, because one of them is a whole number and one of them is not. But then some of you guys like to use a decimal there for that because it didn't come out super clean. So if I type that in the exact way it looks into the calculator, that gets us about 475 and then 0.06 meters squared. So that's an approximate answer. Here's exact, but then your approximate answer is down below that. Okay, as far as your volume goes, you go area of your base times the height, so that height is 8, and then you can go times 54 and then square root of 3. Okay, and that gives you about 432 square root of 3 if you want exact. If you want an approximate answer, times square root of 3, you're going to get 748 and then 0.2, and then that's meters cubed for your volume. And there you go. That's if you have a hexagon. You could do the same thing with a pentagon. You'd probably have to use a little bit of trig instead of, special right triangle right there. So those are about as hard as it gets. I know there's 1 or 2 on the test just like that. So those are kind of a lot there. Okay, find the lateral area, the total surface area, and the volume of the equilateral triangular prism. So actually what's nice about triangular prisms here, we need to find the area of the base. And by the way, here's what's weird about this one here before we even begin. The base, go ahead and highlight this, the base is the triangle. So the area of the base we're not going to be able to find quite yet. The perimeter of the base is 6 plus 6 plus 6. So that's 18 right there. And then the height, this is where you got to be careful. Height's the distance between your bases. So the height's got to be 8 in this case. Okay, so we'll go ahead and start punching that out. Area of your base. Oh yeah, so the triangle right here, what I'm going to do is just redraw another one here. Each side is 6, so if I cut that in half, this little side down here will be 3. And then we can go and use Pythagorean theorem to go find the height. And notice this is the height of the triangle, not the height of the prism. So that's where you got to be a little careful there. So that'd be 3 squared plus x squared equals 6 squared. And actually you can use a special right to do this as well if you wanted to. So that'd be x squared equals 27. Or once you do the square root, I think you're going to get 3 and then square root of 3. And that is for the height of not the prism, but the height of the triangle. So that will help us find the area of the base. The area of the base should be 1/2 the base, so 6, and then times 3 square root of 3 for the height. So when we do that there, that'll get us, what is that, 3, and then times 3, so I think that'll be 9 square root of 3 for the area of your base. And then now we can go and punch out your lateral surface and volume. So lateral area, lateral area, that's going to be P times H. The perimeter was 18, and then we'll do that times 8. And that's going to get us 144 inches squared. Alright, surface area, you're going to take that 144, but then you're going to add on 2 of the bases, so 2 times 9, and then square root of 3. So 2 different ways you can write that. You can't combine these radicals up, so you can just write it like this, 18 square root of 3 like that, or you can type that in one line in your calculator. And that'll get us about 175 and then 0.2. And then that'll be in inches squared. So either one of those right there. The second one's an approximate. Volume you can actually write out rather cleanly. Volume, you just go 9 square root of 3, the area of your base, and then times the height, which was 8. So that gets you 72, and then square root of 3 right there. Then I guess if you wanted a decimal for that, you get approximately 124.7. And that'd be inches cubed. There you go. Alright, almost done there. That's kind of some of the harder problems. Most of them are going to be kind of simple, where it's, you know, maybe like a right triangle where you don't have to do as much, or maybe like just a rectangular prism. But those are some of the harder examples right there. So we're actually almost done. A couple of the cross sections here. Say you got like a diagonal plane going and intersecting a cube, it's going to make this triangular shape. If you got a horizontal plane intersecting a rectangular prism, cross section looks like it'll be a square or some type of rectangle like that. So this one here, identify the horizontal cross section of the prism. So if you did a horizontal, here's a picture of it there. So that would make a pentagon shape. If you did a vertical one going up and down kind of like that, it's actually going to make a rectangle. So a couple of things on the cross sections. Those usually aren't too bad. Usually I'll do pretty good. This is kind of an interesting concept. Like if we revolved this shape right here 360 degrees around the line M, what shape would it make there? So this is kind of what I do on these here. I draw Since it's a rotation, draw like a circle here, kind of like that, and then it should be kind of the same on both sides right there. So this right here, we're going to say this is a hemisphere, or half a sphere, whatever you want to call that. With beef, we did the same exact thing, rotate this thing all the way around. It looks like it's making a circular shape there, and it's got to be symmetric. So that actually makes what we call a cone. We actually get into those, I think, a little bit tomorrow. Whoa, what's going on here? Let's see what's going on with this one. If we rotate this one all the way around, and it's got to be symmetrical, that looks like a very poorly drawn sphere. And then this last one, let's see what happens here. So we rotate that one all the way around. Both of these sides right there. Looks like this one's going to make a cylinder. And there you go. I think that is it for today.